Hello, bedtime thinkers, and welcome to the Bedtime Discoveries. I'm so glad you are here tonight. Together, we'll take a quiet journey to explore the moon's hidden side, a place most of us never see. Yet it holds secrets as old as time itself. When we look up at the night sky, the moon always shows us the same familiar face, the glowing plains and the craters we know so well. But did you know there is another side? A far side, often called the dark side, though it shines with just as much light from the sun. Tonight, we'll gently drift through the history, the mysteries, and the beauty of this hidden half of our closest neighbor in space. Before we begin, I'd love to know where in the world you are watching from tonight. Would you gently type your location and the time on your clock into the comment below? It's always wonderful to see how far our quiet little family has reached across the earth. And if you enjoy this calm exploration, please softly tap the like button and consider subscribing to the Bedtime Discoveries so you never miss another bedtime journey together. When you step outside on a quiet evening and look up at the sky, one of the most familiar sights is the moon. It has been with us since the beginning of human memory, glowing above us, watching over our nights. It has inspired poets, storytellers, travelers, and dreamers all across the world. But when you gaze at the moon, have you ever noticed that it never seems to change its face? Night after night, month after month, the same patterns of dark plains and light-colored highlands greet our eyes. It is almost like a friend who never turns away, always showing us the same expression. This face is so well known that many cultures gave names to its patterns. Some saw the image of a rabbit. Others imagined the figure of a man. In China, people spoke of the moon rabbit, pounding herbs for the elixir of life. In Europe, children were told stories of the man in the moon, watching quietly over the earth. And in the Americas, people traced animals in the shadows, like owls or toads, depending on how their imagination shaped the patterns. For ancient people, the moon's face was more than just a natural feature. It was a companion in the dark, a calendar in the sky. Its changes marked the rhythm of months, tides, and seasons. Yet, even as it shifted from crescent to half to full and back again, the details of its face stayed the same. This unchanging familiarity gave comfort, but it also raised a quiet mystery. Why does the moon only show us one side? What lies on the other half, hidden forever from Earth's gaze? For millennia, no one knew, and so half of our nearest neighbor remained a secret, cloaked in silence and shadow. Since the far side of the moon could never be seen, it lived in the world of imagination. Cultures across the earth wondered what could be there. Some thought it was a mirror image of the side we see. Others believed it was home to gods, spirits, or magical landscapes. The term dark side of the moon became a common phrase, not because it was truly dark, for sunlight touches it just as much as the near side, but because it was dark to us, unseen, unreachable, a perfect canvas for myths and mysteries. In old folklore, storytellers imagined kingdoms hidden there. Some said it was where the spirits of the departed journeyed. Others believed it was the place where secrets of creation were written in stone. The mystery of the far side stirred human curiosity. We have always wanted to explore, to look beyond horizons, to uncover what is hidden. The far side of the moon was perhaps the greatest nearby mystery. So close yet invisible, so present yet unknowable. And as science slowly grew, from the days of Galileo's telescope to the age of rockets and spacecraft, that longing only deepened. What was this other face? Why had nature kept it hidden from us? Today, we know much more about the moon's hidden side. We have photographs, maps, and even rovers exploring its surface. But to understand the importance of what we found, we must first appreciate the mystery it held for so long. Imagine standing on Earth thousands of years ago, looking up night after night at the same familiar features. The Sea of Tranquility, the ocean of storms, the round scars of impact craters, and always wondering what lies on the unseen half. This was one of humanity's earliest unanswered questions, a mystery that seemed unsolvable until the tools of space exploration arrived. The moon, in a way, has two personalities. One face turned toward us, bright, familiar, and almost friendly. The other turned away, silent, hidden, and waiting to be revealed. As we begin this journey together, exploring both the seen and the unseen, we step into a story that is as much about human curiosity as it is about rocks and craters, because the hidden side of the moon reminds us that even the closest things in our universe still have secrets to share. If you've ever watched two dancers moving together, you'll notice how sometimes they turn in perfect rhythm, so that one dancer's face is always directed toward their partner. This image is a simple way to picture why the moon always shows us the same side. The moon is locked in what scientists call synchronous rotation, but in softer words, we can think of it as a rhythm, a cosmic balance. The moon spins on its axis, the same way Earth does, but it spins so slowly that it takes about 27 days to complete one full turn. And in that same time, it also orbits Earth once. This means that as it moves around us, its spin perfectly matches its journey, so it never turns its far side toward Earth. It's as if the moon is whispering, "This is the face I've chosen for you to see. The other will remain my secret." We call this tidal locking, and it is not unique to the moon. Many moons in our solar system, especially those orbiting close to their planets, are tidally locked too. For example, Jupiter's large moon like Io and Europa also keep one face toward their giant planet. It is a natural outcome of gravity, pulling and shaping until rotation and orbit fall into harmony. To ancient eyes, this locking was invisible. People simply saw the moon as a constant friend. But today, with the language of science, we can understand the quiet dance of forces that makes it so. Tidal locking begins with gravity. Earth's gravity pulls strongly on the moon, and the moon pulls back. Just as the moon raises tides in our oceans, long ago, Earth's pull raised tidal bulges on the moon itself. These bulges created friction within the moon, slowing its spin little by little over millions of years. In its early life, the moon spun much faster. Different faces would have looked down on Earth as it twirled in space. But as time passed, the tug of Earth's gravity acted like a brake, until at last, the moon's rotation slowed to match its orbit. And from that moment on, the same face was always turned toward us. It is humbling to think of how long this took. Hundreds of millions of years of gentle, invisible tugging, until the moon and Earth settled into their eternal dance, one turning around the other, locked in a rhythm so steady that it seems unchanging to us. This tidal interaction also affects Earth. Though less noticeable, the moon is slowly causing Earth's own rotation to slow down. Our days are lengthening by just a tiny fraction of a second each century. Far in the future, the balance will be different again. But for our lifetimes and for the lifetimes of all human history, the moon has remained faithfully the same. Though we say the moon always shows us one side, in truth, we can see just a little more. because the moon wobbles slightly in its orbit. This gentle rocking motion is called libration. It allows us to peek beyond the edge, revealing about 59% of the moon's surface over time. To the patient observer, this means that the moon's face is not entirely fixed. Its features sway slightly back and forth, as if nodding, inviting us to glimpse just a little beyond the curtain, though never fully lifting it. This wobble gave astronomers hints, long before spacecraft, that the moon might have more to reveal than its quiet, constant mask. But until modern times, the far side remained unseen. And so, the reason we always see the same face is both simple and deeply poetic. It is gravity shaping time and motion into harmony. It is Earth and Moon locked in a slow embrace. It is nature's way of balancing, until even celestial bodies learn to dance together. For as long as humans looked up at the moon, we only knew half of its story. Night after night, generation after generation, people saw the same craters, the same plains, the same quiet features. It was a trusted companion, but a companion that kept one side forever hidden. The far side of the moon became a canvas for imagination. In myths, it was a secret land. In stories, it was the dwelling of spirits or gods. Even scientists of earlier centuries wondered, was the far side a mirror image of the near side? Or might it hold strange landscapes, mountains taller than Earth, valleys deeper than we could imagine? But despite the longing to know, the far side remained unreachable. No telescope on Earth could peer around the moon's curved body. No explorer, no invention, no dreamer could ever catch a glimpse until the age of space exploration dawned. In the mid-20th century, humanity built rockets powerful enough to leave Earth's atmosphere. And with those rockets came the chance to solve one of our oldest skyward mysteries. It was the year 1959. The Cold War was reshaping science and exploration. The Soviet Union and the United States were locked in a race for the stars. And the moon, that familiar friend, became the first target. Among the early attempts, one mission stood out: the Soviet spacecraft Luna 3. It would become the first to slip behind the moon and reveal to humanity the hidden half for the very first time. On October 4th, 1959, just 2 years after the launch of Sputnik, Luna 3 was sent into space. Its mission was bold: to travel around the moon, swing behind it, and send back pictures of the unseen side. Imagine the tension as scientists and engineers waited. Would the camera survive the journey? Would the spacecraft succeed in turning, pointing, and snapping its images? Would the film, yes, actual photographic film, develop properly in the vacuum of space? For Luna 3 did not use digital technology. It carried chemical film. Inside its tiny body was a miniature darkroom where exposed images were developed, scanned line by line, and transmitted back to Earth as radio signals. After days of silence, signals began to arrive, and with them, the very first ghostly photographs of the moon's hidden face. The images were grainy, blurred, almost dreamlike, but they were historic. For the first time, humankind could see what had been hidden for billions of years. What they revealed astonished scientists. The far side was very different from the familiar near side. Instead of wide, dark plains, it was dominated by rugged highlands and countless craters. Only a few small patches of darker surface appeared, and these were nothing like the vast Maria of the near side. The mystery of the far side was no longer complete. It had stepped out of legend into science, and though the images were imperfect, they were enough to change forever the way we thought of our closest neighbor. Those first photographs from Luna 3 were shared around the world. printed in newspapers, studied by scientists, and gazed at by ordinary people. It was as if humanity had opened a door into a hidden room, one that had been locked since the beginning of time. The excitement was not just scientific. It was deeply emotional. For the first time, we realized that the moon was more than the familiar face we knew. It had another personality, another story, written in craters and mountains we had never dreamed of. The far side became a new frontier, a symbol of what technology could reveal, and a reminder that the universe still held secrets waiting to be uncovered. In the years that followed, better missions would return sharper images. The United States sent spacecraft that mapped the far side in greater detail. And eventually, astronauts in orbit around the moon during the Apollo missions could glimpse it with their own eyes. But Luna 3, with its fragile technology and blurry pictures, holds a special place in history because it gave us the very first glimpse. It was the moment when myth became reality, when imagination gave way to knowledge, when humanity, for the first time, looked at the face of the moon that had always turned away. And perhaps it is this moment that most perfectly captures the spirit of discovery, the quiet thrill of seeing something utterly new, not far away, not on some distant star, but right beside us, hidden all along. When Luna 3 sent back its faint images, the world gasped, for the moon we thought we knew turned out to have two very different personalities. The near side, the one that smiles down at us each night, is marked by broad, dark plains. These plains are called Maria, from the Latin word for seas, because early astronomers imagined they were filled with water. Of course, they are not seas of water, but ancient lava flows, smooth surfaces of cool volcanic rock. When you look up at the moon with your eyes alone, or even with a small telescope, the Marias stand out clearly. The sea of tranquility, the sea of serenity, the ocean of storms, each given poetic names by astronomers of long ago. These Maria cover large portions of the near side, making it look familiar, calm, and patterned, almost like a face with eyes, nose, and mouth drawn in shadows. But when the first images of the far side arrived, scientists were startled. Instead of smooth, dark seas, the far side was almost entirely rough and rugged. Mountains piled upon mountains, craters overlapping in endless chains, and hardly any Maria at all. It was as if the moon showed Earth its calm, friendly mask, while keeping its stormier, more ancient side turned away. The difference was not subtle, it was striking. Two halves of the same world, yet shaped in very different ways. Why does the near side look so different? The story lies in its history of impacts and volcanoes. Billions of years ago, the young moon was battered by asteroids and comets. On the near side, when giant impacts punched deep holes into the crust, molten rock from below welled up, flooding the basins with dark lava. These floods cooled into the flat plains we see today. The far side, however, tells a different story. Its crust is much thicker and harder to break through. When impact struck, the lava beneath could not easily reach the surface. So instead of wide plains, the craters remained scar upon scar, frozen in time. This means the near side shows a mixture of youth and age. Its Maria are relatively younger surfaces, formed perhaps 3 billion years ago, while its highlands, still visible, are much older. But the far side is almost entirely ancient, preserving the rugged record of impacts stretching back more than 4 billion years. In a way, the near side is like a page of history partly rewritten, its older marks covered by newer flows of lava. The far side is like a library untouched, every scar still visible, every story still preserved. When Apollo astronauts orbited the moon, They saw this contrast with their own eyes. Looking down on the near side felt almost familiar, but as their spacecraft slipped around the curve into the far side, the landscape changed dramatically, like stepping from a garden into a wilderness, untouched, raw, and wild. These surface differences are more than just appearances. They tell us about the moon's inner structure and its long history. The near side's thinner crust may have been caused by the way the moon formed. Some scientists suggest that when the moon was young, still molten inside, heat was trapped unevenly. The near side, facing Earth, may have stayed warmer, allowing its crust to remain thinner. The far side, cooling more quickly, grew a thicker crust resistant to lava flows. This difference shaped everything that followed. Impacts that hit the near side often became smooth maria, while impacts on the far side became rugged basins, filled with craters but not with lava. Even today, scientists study these differences carefully. By comparing rocks brought back from the near side with data from spacecraft orbiting the far side, they piece together the story of how the moon evolved. For us, looking up at the moon, it is a gentle reminder that appearances can be deceiving. What seems like one simple world actually holds two very different faces, each with its own history. And in that contrast, we find beauty. The near side's familiar seas, glowing softly in the night sky, and the far side's rugged wilderness, hidden from us, but now mapped in detail. Together, they make the moon not just a companion, but a storyteller, carrying within it the tale of fire, stone, and time. When Luna 3's photographs first reached Earth, scientists noticed something strange. On the near side, vast dark maria stretched across its surface. But on the far side, almost none could be found. It was as though one half of the moon had been painted with wide, dark strokes of lava, while the other half remained pale, rugged, and untouched. This imbalance puzzled researchers. Why should one face of the moon be covered in smooth volcanic plains, while the other remained almost entirely crater highlands? For decades, this question lingered like a quiet riddle in lunar science. To solve it, scientists had to look deep into the moon's crust, its mantle, and even its earliest beginnings. The key lies in the thickness of the moon's crust. The near side has a thinner crust, allowing molten rock to break through after giant impacts. The far side, by contrast, has a crust so thick that magma beneath could not easily escape. And so, while both sides were battered by impacts billions of years ago, only the near side's wounds were flooded and smoothed by dark lava seas, leaving the far side scarred, ancient, and rugged. But why is the crust thicker on the far side? Here, science offers several general theories. One idea is that in the moon's early days, when it was still molten, heat was not spread evenly inside it. The side facing Earth may have cooled more slowly because Earth's gravity tugged on it, keeping its interior warmer for longer. The far side, turned away, cooled faster, forming a thicker shell. Another theory suggests that radioactive elements like uranium, thorium, and potassium gather more on the near side. These elements produce heat as they decay, which may have kept the near side hotter and its crust thinner. Think of it like baking bread. If one half of the loaf cools quickly, it forms a thick crust, but the other half stays warm and soft with a thinner crust. The moon in its youth may have baked unevenly, leaving it forever lopsided. Over time, this difference shaped everything that followed. When giant asteroids struck the near side, the thinner crust cracked. Lava welled up from below, spreading across basins to form maria. But when the same kind of impacts hit the far side, the thick crust resisted. So instead of lava seas, Only deep craters remained. This quiet difference, born billions of years ago, explains the strange imbalance we see today. The far side's lack of Maria has become a gift for science because its surface was never flooded by volcanic rock. It preserves the record of the moon's earliest impacts. By studying the far side, scientists can glimpse the ancient history of the solar system, the scars of collisions that shaped not just the moon, but Earth as well. It also reminds us of how delicate the balance of nature is. Two halves of the same world, formed at the same time, yet small differences in heat and crust thickness led to very different faces. The near side is younger, smoother, more familiar. The far side is older, rougher, and more secretive. Together, they tell a story of contrast, of how cosmic forces shape worlds in uneven, unexpected ways. And perhaps there's a quiet beauty in this imbalance. For if the moon had been the same on both sides, it would not have held the same mystery. It would not have drawn us to wonder about the unseen, and it might not have inspired the same longing that led us, at last, to reach for it with our spacecraft and our dreams. Far on the moon's hidden side lies a feature so vast, so ancient, and so mysterious that humbles even the most experienced scientists. It is called the South Pole Aitken Basin, often shortened to SPA Basin. This is not a simple crater. It is one of the largest known impact structures in our entire solar system. Imagine an oval stretching 2,500 kilometers across, nearly 1/4 the width of the moon itself. From the moon's south pole, all the way northward to the crater Aitken, its depth plunges 8 to 13 kilometers below the surface. So deep that its lowest points are among the very deepest places on the moon. This colossal scar was formed billions of years ago by an impact so powerful that it shook the entire moon. An asteroid or comet, perhaps 150 to 200 kilometers wide, struck the surface at tremendous speed. The explosion excavated material from deep within the moon's crust and maybe even from its mantle, leaving behind a basin larger than many countries on Earth. To stand on its rim, if humans ever do, would be to gaze across a horizon so wide it would vanish into the distance, like looking across an endless, rocky sea. The South Pole Aitken Basin is more than just a scar. It is a window into the moon's deep history, a silent witness to violent events that shaped not only the moon, but the early Earth as well. The SPA Basin has become one of the most studied regions of the moon, not because it is easy to see. In fact, from Earth, it is forever hidden, but because it holds clues that no other place can provide. Scientists believe that the impact which created it was so powerful, it may have dug down into the moon's mantle. If so, rocks from deep inside the moon could be exposed on the surface. Studying them could reveal what the moon, and by extension the Earth, was made of more than 4 billion years ago. Orbiters have mapped the basin in detail, using cameras, spectrometers, and instruments that measure gravity. They found that the basin's floor has unusual minerals, such as thorianite and pyroxene, materials that suggest a deep, ancient origin. The basin also affects the moon's gravity in strange ways. Spacecraft flying over it feel tiny changes in pull, evidence of the immense mass shifts created by that long-ago impact. One of the basin's most mysterious features is its asymmetry. Its floor is not smooth, but filled with mountains, ridges, and smaller craters formed later. It is a landscape of chaos frozen in stone. And yet, despite its violence, it is also strangely quiet. No air stirs there. No sound carries. Only the silent mark of collision that happened before life even began on Earth. The South Pole Aitken Basin is more than a relic of the past. It may also be a guide to the future because of its depth and location. Sunlight strikes parts of the basin unevenly. Some craters near the South Pole remain in permanent shadow. These dark, frozen places may trap ice. Ice that could one day be used by explorers for water, air, and even fuel. For this reason, the basin has become a target for missions. China's Chang'e for lander and rover, for example, touched down in 2019 inside the basin, becoming the first spacecraft ever to land on the moon's far side. Its discoveries are still helping us understand the rocks, soil, and hidden ice. In the future, NASA and other space agencies dream of sending missions to bring samples back from this basin, pieces of rock that may have been untouched for billions of years, carrying secrets of the moon's mantle and perhaps the earliest days of the solar system. For scientists, the South Pole Aitken Basin is like a time machine. By studying it, they hope to learn how giant impacts shaped not only the moon, but Earth, Mars, and even conditions for life itself. And for dreamers, it is a reminder of the vast power of the cosmos. A single collision, billions of years ago, carved a scar that endures to this day, a silent monument to the forces that build and break worlds. The moon's far side, the hidden hemisphere that never faces Earth, is not just a place of mystery. It is also one of the most valuable scientific laboratories in our solar system. Unlike the side we see from Earth, the far side is shielded from much of our planet's noise. Radio signals, for example, cannot easily reach it. That means in those shadowed valleys and basins, the far side offers something incredibly rare, a place of pure silence. For scientists, this silence is golden. Radio astronomers dream of placing telescopes on the far side, instruments that could listen to the faint whispers of the universe, signals from the time before the first stars and galaxies lit up. On Earth, those signals are drowned out by our phones, satellites, and even the atmosphere. But on the moon's far side, they could be heard, like faint echoes from the beginning of time. And that is only the beginning. The far side also preserves a different geological history than the near side. Its surface, thicker and more rugged, has been less smoothed by lava flows. So it holds an older record, a more complete diary of impacts, craters, and cosmic events. To scientists, it is like a library of stone where each crater, each ridge, each mineral grain tells a story. Stories of how the moon evolved and how Earth itself was shaped in the same violent era. When scientists look at the moon's far side, they are not only studying the moon, they are also seeking clues about the Earth, Mars, Venus, and even the building blocks of the solar system itself. You see, the moon formed in the aftermath of a great collision. Long ago, a Mars-sized body struck the young Earth. From the debris, the moon emerged. That means the moon's rocks contain echoes of Earth's earliest materials. On the near side, much of that story has been covered by ancient lava seas, called Maria, but the far side, with fewer Maria, keeps a raw record. Its crust is thicker, perhaps because of how the moon cooled unevenly after formation. This difference gives us direct evidence of how a planet-sized object behaves after being born in chaos. Studying the far side also helps scientists understand the bombardment history of the inner solar system. Billions of years ago, countless asteroids and comets rained down. On Earth, erosion and tectonics have erased much of that record. But the moon's far side still carries the scars, untouched, unaltered. Each crater is like a page, and together, those pages reveal how often impact happened, how big they were, and how they influenced the chances for life to emerge on Earth. So, The far side is not only about the moon itself. It is a place where we can look backward in time to learn about the conditions that shaped our world and, perhaps by extension, the conditions that shape worlds beyond our solar system. The far side scientific value is not only historical, it points forward toward discoveries yet to come. For example, imagine building a network of radio dishes within one of its deep craters, listening to signals from the cosmic dark ages, the time before the first galaxies formed. Such a telescope could answer some of the most profound questions of cosmology. How did the universe begin? When did the first light shine? Or picture astronauts one day walking across its rugged terrain, collecting samples untouched for billions of years, bringing home rocks that might reveal minerals never seen before. The far side might also hold resources, not only water ice and shadow craters, but rare minerals deep in its crust. While scientists dream of knowledge, explorers dream of sustainability, and the far side could one day serve as both. Even more, it offers perspective. When you stand on the near side of the moon, you see Earth rising and setting, but on the far side, the Earth never appears. The sky is filled only with stars and the sun and planets. It is a place of eternal separation, and in that separation lies a unique opportunity to study the universe in peace. For scientists, the far side is both a treasure chest and a time capsule. It preserves history, it shields silence, and it points the way to the future. On Earth, our skies hum with invisible signals. Television broadcasts, phone towers, satellites, radar, even the whispers of Wi-Fi. All these fill the air with a steady background of radio noise. But on the far side of the moon, there is silence. A deep, profound silence, unlike anywhere else in our solar system. You see, the moon itself acts as a shield. Its entire bulk blocks the constant storm of radio waves coming from Earth. So when you step behind the moon, Earth's chatter falls away. No more human-made signals, no more interference, just a stillness so complete it feels like stepping outside of time. This silence is not just poetic. It is scientific gold. Astronomers have long dreamed of listening to the universe without Earth static in the way. On the far side, in its craters and valleys, we can finally do that. The silence makes the moon's hidden hemisphere the perfect place to hear the faintest signals, echoes of the universe when it was young, radio waves from the era before the first stars ignited, faint whispers that our noisy planet can never allow us to catch. In this way, the far side of the moon becomes not only mysterious, but sacred, a sanctuary of silence, waiting to reveal secrets of the cosmos. Imagine, if you will, a great bowl-shaped crater hidden on the far side, its walls rising like natural shields, its floor resting in quiet shadow. Now, picture a vast radio telescope built within it, a dish stretching hundreds of meters across, listening, night after night, to the music of the universe. Such dreams are not new. Scientists have proposed building giant radio observatories in craters like Daedalus or Tsiolkovsky. Others imagine lightweight antennas, spread across the soil like spiderwebs, linked together to form enormous arrays. What would they listen to? Not the familiar signals of galaxies and stars we already study on Earth, but older, fainter whispers. There is a time in the universe's story known as the cosmic dark ages, after the Big Bang, but before the first stars were born. During that time, hydrogen-filled space, quietly glowing with radio energy. Those signals still drift through the cosmos, but on Earth, they are lost in a fog of noise. On the moon's far side, they could be captured. A telescope there could open a window into a time we have never directly observed. It would let us see how the first stars formed, how galaxies gathered, and how the universe began to shine. The silence of the far side could also reveal bursts of energy from distant planets, pulsars, and black holes, signals so delicate that they vanish in the noise of Earth. But in lunar quiet, they may sing clearly. This is why many scientists believe the far side of the moon may one day become the greatest listening post humanity has ever built. There is something poetic about the silence. For billions of years, the far side has been hidden from Earth, unseen, unheard, untouched. And in that hiddenness, it has preserved a gift, a shielded, perfect quiet. Explorers who first orbit behind the moon often describe a strange feeling. When Earth disappears, so does radio contact. For a few minutes, they are cut off from all communication. It is both unsettling and profoundly peaceful. One astronaut once said it felt like being alone with the universe. For scientists, this gift of silence could transform our understanding of the cosmos. For dreamers, it speaks to something deeper, that sometimes the greatest discoveries happen not in noise, but in quiet. When humanity builds its first great radio observatories on the far side, it will be like placing an ear to the universe's earliest heartbeat, a way of listening not just across space, but across time. And perhaps when explorers stand in one of those silent craters, gazing at the star-filled sky with Earth forever hidden, they will feel what we feel now, that the moon's far side is not just a place of rock and dust, but a sanctuary, a cathedral of silence, where the universe itself may whisper its oldest secrets. Long before humanity ever walked upon the moon, we gazed upward and wondered what lay beyond the familiar face. The moon's near side, always turned toward Earth, showed us its bright highlands and dark Maria. But the far side remained a mystery, a hidden world forever out of sight. For centuries, astronomers imagined what it might look like. Some thought it mirrored the near side, with matching seas and craters. Others believed it might be smooth, or even covered with features unlike anything we knew. But there was no way to see it until the dawn of the space age. In 1959, the Soviet spacecraft Luna 3 became the first mission to change everything. It carried a simple camera wrapped in layers of protection, sent on a path that swung it around the moon. As it drifted past, Luna 3 turned its lens toward the unseen hemisphere, and for the very first time, humanity saw pictures of the far side. The images were blurry, ghostly shadows and bright patches, grainy as though seen through a foggy glass. Yet they revealed something astonishing. The far side looked nothing like the side we knew. Instead of broad, dark Maria, it was rugged, mountainous, and scarred with countless craters. This was a land older and wilder than the near side, and the revelation reshaped our understanding of the moon. Those first photographs captured the imagination of the world. Though they were rough, they showed that the far side was not a twin, but a stranger. From that moment, the moon's hidden hemisphere became a frontier, not just of science, but of wonder. Through the 1960s and 1970s, other missions followed. The lunar orbiters, then America's Apollo missions, mapped more and more the far side. Apollo astronauts, orbiting in their command modules, described the eerie experience of slipping behind the moon. As they crossed the line of sight, Earth vanished, radios fell silent, and for nearly an hour, they were cut off completely. Astronauts often said it felt lonely, yet awe-inspiring. The far side stretched below them, an endless desert of craters, bathed in sunlight, while the universe shimmered above. These early explorations, though brief, laid the foundation. They gave us maps, photographs, and the first taste of lunar solitude. But they were only the beginning. The far side still waited, untouched by human hands, unvisited by landers. A place seen but not yet known. Decades passed. For a long while, exploration of the far side slowed. After Apollo, interest waned, and robotic probes turned their attention elsewhere, to Mars, to asteroids, to the outer planets. Yet the far side remained patient and silent. Then, in the 1990s and early 2000s, new orbiters began to revisit the moon. NASA's Clementine and Lunar Prospector, Europe's Smart 1, Japan's Kagaya, and India's Chandrayaan. One all mapped the far side with modern instruments. Their cameras were sharper, their sensors more precise. They revealed deep basins, unusual minerals, and possible hints of frozen water in shadow craters. These missions prepared the way for something greater, the first true landing on the far side. In January 2019, China's Chang'e 4 mission made history. It carried a lander and a rover, touching down inside the von Karman crater, within the Great South Pole Aitken Basin. For the first time in all of human history, a spacecraft had gently set its feet on the far side of the moon. This was not a simple task. Because the far side never faces Earth, radio signals cannot pass directly. To solve this, China launched a relay satellite, Keiqiao, to orbit a point beyond the moon. From there, it could see both Earth and the lander, passing messages back and forth like a cosmic postman. Once Chang'e 4 landed, it opened a new chapter. Its rover, named U-2, rolled onto the surface, slowly and carefully. Together, they began sending back stunning photographs, sharp, clear, and colorful. The far side, once a blurry mystery, now appeared in crisp detail. Scientists studied the soil, the rocks, the strange layers of regolith. They measured radiation, scanned minerals, and even grew tiny plants inside a sealed container carried aboard. For the first time, the far side was not only seen, but touched, studied, and explored. The mission is still active today, continuing to roam, observe, and teach us. Its success proved that humanity can not only orbit the far side, but live and work upon it, if only with machines for now. Other nations have taken note. Future missions, from NASA's Artemis program, from Russia, India, and private companies, all at the far side as a place of immense value. It is no longer a shadowed mystery. It is a destination. What lies ahead for far side exploration? Much, much more than we have yet seen. In the coming years, scientists dream of sending landers to the deepest craters of the South Pole, Aitken Basin. Some hope to drill into its rocks, to bring samples back to Earth. Others envision radio telescopes, listening to the whispers of the early universe, built upon its silent plains. NASA has planned robotic missions through its Commercial Lunar Payload Services program, small landers that could carry instruments to different sites. There are proposals for sample return missions that could finally place far side rocks in human hands. And then, beyond machines, come people. The Artemis program, aiming to return astronauts to the moon, will first focus on the South Polar region. But in time, explorers may journey farther, perhaps to the far side itself. Imagine astronauts standing within a crater, Earth forever hidden beyond the horizon. Above them, the stars blaze unhindered, the Milky Way glowing with clarity no one has seen since before radio towers filled our skies. These missions will not only expand our science, they will expand our spirit, for the far side is more than terrain. It is a symbol of hiddenness, of patience, of silence that holds meaning. Each mission, past and future, is like a stepping stone across a dark, ancient sea. From Luna 3's first ghostly photograph to Chang'e 4's living rover, to the explorers yet to come. Humanity is slowly weaving a bridge between what is known and what is hidden. The far side still waits, but no longer as a stranger. Now, it waits as a friend not yet fully met, a place where science, wonder, and human courage will continue to entwine for decades, perhaps centuries, to come. Imagine it is some quiet decade not too far into the future. A spacecraft drifts silently into orbit around the moon. Inside, astronauts float, gazing down at landscapes no human eyes have ever seen directly. The rugged far side, bathed in sunlight, Earth absent from the sky. For the first time in history, humanity is not only imagining the far side, not only sending robotic visitors, but preparing to place human footsteps upon its soil. The near side, with its familiar Earthrise, has already become a place of return through missions like Artemis. But the far side offers something even more profound. It offers true separation, a chance for explorers to stand on a world where Earth is forever hidden below the horizon. Scientists envision bases near the South Pole, Aitken Basin, where sunlight and shadow intermingle. Some craters remain in darkness, locking away frozen water ice. Others bask in near constant sunlight, ideal for solar power. Together, they create an environment where human explorers might one day build habitats, mine ice for drinking water, and split it into hydrogen and oxygen for rocket fuel. Walking across that ancient ground, astronauts could collect rocks older than any we have studied. They might drill into the crust, uncovering minerals that carry whispers from the moon's mantle. Each sample would be like a message sent from billions of years ago, a record of how worlds form, collide, and evolve. And when those explorers looked upward, they would see a sky unfamiliar to earthbound eyes. No blue dome, no rising planet Earth. Instead, stars unbroken, uninterrupted, more brilliant than anywhere on Earth's surface. They would stand in a silence so pure, a solitude so vast, that even their own voices, muffled inside helmets, would seem out of place. This is one possibility. A future where humanity learns not just to visit the far side, but to live there, even if only for short stretches. A future where astronauts become caretakers of silence, guardians of one of the most sacred places in the solar system. Another future possibility reaches far beyond geology or exploration. It is a dream of turning the far side into humanity's greatest listening post, a place where the universe itself could whisper its deepest secrets. On Earth, our atmosphere, our electronics, and our endless radio chatter fill the skies with noise. But on the far side of the moon, as we explored in Keynote 8, there is a shield, a perfect silence. Into that silence, scientists imagine lowering great antennas into craters. Some propose stretching ultra-lightweight wires across the regolith, forming a radio array that could detect signals from the cosmic dark ages, the period after the Big Bang, but before the first stars formed. Others dream of building telescopes inside massive natural craters, turning them into bowls that gather radio waves from across the universe. These instruments could reveal the birth of the very first stars and galaxies. They could detect faint signals from distant planets, perhaps even signatures of alien magnetic fields. Clues that another world might harbor life. The far side could become the place where humanity listens not only backward in time, but outward across the galaxy. Picture a small team of astronauts, or even robots, maintaining such instruments. Each day they would check arrays, adjust sensors, and ensure that the moon's silence remained undisturbed. Each night, though lunar nights last 2 weeks, their instruments would record cosmic symphonies no one has ever heard. These listening posts could redefine our place in the cosmos. They could help us answer the greatest questions. Where did we come from? When did the first light shine? And are we alone in this vast universe? The far side would no longer be only a geological treasure. It would be a cosmic observatory, a window into eternity. But the possibilities stretch even farther, into the realm of imagination, where science and wonder blend. One day, perhaps centuries from now, there may be small communities on the moon, domes or underground habitats where families live and work. Children might grow up seeing the sun rise slowly over crater walls, learning to walk under weaker gravity, playing on fields of dust that shimmer silver in starlight. On the far side, those settlements would have no view of Earth. Instead, their windows would open only to the deep universe, a constant reminder of humanity's place among the stars. Perhaps such a community would see itself less as Earthlings and more as citizens of space. There are even visions of turning the far side into a kind of cosmic park, a protected region where radio silence is preserved, where telescopes are built with care, and where tourism is balanced with scientific discovery. Future travelers, wealthy adventurers, or perhaps even everyday people might one day walk on the far side, guided overlooks where they can see the endless sweep of craters. They might sit in silence, gazing upward, feeling what no human has ever felt before, the experience of truly being beyond Earth's gaze, and still farther into the future, as humanity expands outward to Mars, to asteroids, and beyond, the far side of the moon may remain a touchstone, a place to pause, to reflect, to listen, a reminder that while technology carries us outward, silence and stillness carry us inward. The far side may become not only a place of science, but a place of philosophy, where each generation rediscovers the importance of patience, hiddenness, and wonder. The moon's hidden side began as a mystery. It became a frontier of exploration. Now it is a canvas upon which humanity paints dreams of science, exploration, and even quiet reflection. The far side holds within it endless futures. Futures of footsteps, futures of listening, futures of community. And in all of them, one thread remains constant. The gentle reminder that sometimes the most beautiful places are those that wait patiently, unseen, until we are ready to discover them. And so, dear listener, our journey through the mysteries of the hidden moon comes to a gentle close. We have wandered through craters bathed in silence. We have listened to the whispers of ancient rocks. We have imagined telescopes stretching into the stars, and footsteps waiting patiently to be placed upon untouched ground. Each chapter was a window not only into science, but into wonder itself, a reminder that beyond the noise of everyday life, there are places vast and still, waiting quietly for us to notice. The far side of the moon may be distant, but its silence reaches us here, calming our thoughts, slowing our breathing, and wrapping us in a blanket of peace. As you drift toward rest, let your mind float gently like a spacecraft in orbit, suspended between starlight and shadow. There is no hurry now, only stillness, only calm, only the endless quiet of space, holding you softly through the night. May your dreams tonight be filled with wonder, with discovery, and with peace. Until we meet again beneath the stars, I wish you comfort. I wish you rest. I wish you the gentlest of nights. Good night, dear dreamer. Goodbye,